This video is about the database SQL package in Go and how we can connect our Go applications to relational databases. So we're going to connect Go to a PostgreSQL database that's running in a Docker container in this video. We're then going to create a table in that database and then run some queries to fetch data and insert data into that table. And this is a foundational video. We'll use concepts that we learn about in this video in future videos on how to use Go with html and also with React applications. So let's get started. And this is the package that we're going to use in this video. It's the database SQL package that's built into the Go standard library. And this package provides a generic interface around SQL databases. So the interface that's provided by this package can be used with all sorts of different relational databases, for example, Postgres and MySQL. In this video, we're going to look at Postgres specifically, and we're going to use this Postgres Docker image from Docker Hub. So what I'm going to do is copy the Docker pull command, and we're going to use that command in the terminal that I'm going to bring onto the page now. And I'm going to paste that in here, and that's going to pull the PostgreSQL database image to our local system. Once that's completed, we can then start up a Docker container from this image containing the Postgres database. So in order to do that, I'm going to go back to the documentation and I'm going to scroll down a little bit here, and we're going to go to the section on how to use the image. And there's a sample Docker run command here that contains some arguments to the run command. For example, we give the container a name and we set some environment variables and other information. So what I'm going to do is go back to the terminal here, and I'm going to run that Docker run command, and let's give the container a name of Postgres-container here, and we're going to set the Postgres password environment variable here. So it's going to be Postgres password, and we're going to set that equal to, let's just say, secret in this application. We're then going to create a port mapping on this container. So on port 5432 on our host, we're going to map that into the same port on the container, and that's going to allow us to connect to Postgres from our local machine into that Docker container that runs the database. The final argument we're going to pass is the -d argument. That's going to start the container in detached mode, and that will start the container in the background. And finally, we specify the container, or rather the image we want to start this container from, and that's the Postgres image that we just pulled from Docker Hub. So we can run this command and we get back the image ID, or the container ID here. I'm going to clear the terminal and we can run docker ps, and we can now see that the Postgres container is running on our system. So what I'm going to do now, just before we start writing some code, is I'm going to go into the database here that we've started, and I'm going to create a database on that database server so that we can connect to that database and then run the commands and queries that we're going to run from our Go application. So we've got this container running. It's got the name of PG container. I'm going to copy that, and what we're going to run is the docker exec command, and we're going to run this in interactive mode with the -ti flag. And then we can paste the name of the container that we want to connect into here. And the command that we're going to run in the container is the create db command. And what we do here is we create a database on the running PostgreSQL database server using this create db command. And we are going to specify the user of Postgres and the name of our database. I'm going to call that Go Postgres Test. So what's going to happen here, it's going to create this database with this name on the server. So let's run this command and we can see what happens. We don't actually need the -ti flag here either because we're running a one-off command. But once that's completed, we can run another command here. So I'm going to clear out the create db command, and I'm going to run the PSQL command. And again, when we're connecting to the Postgres command line tool, we need to specify the user. I'm going to specify Postgres here. And then what we can do is we can switch over to our database. Now by default, when you connect using PSQL, the database that we're connected to here is called Postgres. We can use the /c command in PSQL and specify another database name. So the one that we created was called Go PG Test. We can now connect to that and we can see that it actually does exist after we use this create db command. So let's now quit out of pSQL and we're going to go back to the terminal, and actually let's go to VS Code where we're going to start writing some Go code. Now I have a very simple Go file here. It's called main.go and it contains an empty main function. What we're going to do is connect to the database. So what we need to look at here is the SQL package from Go. And if you look at the sidebar here, we can search for a particular function, and the one I'm going to look for is a function called open. So let's find that and we can go to the documentation. This function will open a database as specified by the database driver name, which is the first argument to this function. And what this function is going to return is a pointer to an sql.db object that represents our database. Now the first argument is the driver name. This is dependent on which database you're connecting to. We're connecting to PostgreSQL, so we need to get a Postgres specific driver for Go. And the package I'm going to use for that is this pq package. And this is not built into Go's standard library, so we're going to have to run this command, go get, in order to pull that into our application. But this pq package is a pure Go Postgres driver for the Go SQL package. So we're going to pull that into our application so we can connect to PostgreSQL. I'm going to copy this command here, and we're going to go back to VS Code, and I'm going to start up a terminal here. So I've got that terminal open at the bottom. What we need to do now is initialize a go.mod file that's going to track the external dependencies that we're using in this Go application. So what I'm going to run here is a command, and it's the go mod init command, and the module that we have is the main module, so I'm going to specify that main module, and that creates the go.mod file that you see here on the left hand sidebar. And currently we have no external dependencies, but what we're going to do now is paste in that go get command that we got from the pq package. So let's paste that in, and that's going to download that package source code from GitHub, and it's then going to make that available in our application. And if we now open the go.mod file, you can see that we're requiring this pq package. So let's start writing some code in this file here. I'm going to close go.mod, and in the main function we're going to initiate a connection to the running Postgres database, and to do that we're going to use this open function that we saw in the documentation. So let's get started with that now. What I'm going to do at the top of this function is define a connection string. This is a Postgres connection string, and you can see that this hard codes things like the password in the string. Not the best practice in a real application, but we're just going to do that in this video just to make things very simple. So this connection string contains all the details that we need to connect to Postgres. It has the username, it has the password, and we have the host, which is just localhost because of that port mapping into the Docker container. And finally we have the name of the database that we're going to connect to, and that's the 𝗵PG test database. Once we've got that, we can call the sql.Open function from the Go SQL module. So if I save this file, you can see it auto imports the SQL module. The first argument to open was the name of the driver, and because we're connecting to PostgreSQL, we're going to specify Postgres here, and the second argument to that is going to be the connection string. Now if we look at the documentation here, you can see that this returns a pointer to an sql.db object and also an error. So let's get those objects as the return statement. We're going to create a db, and we're also going to create an error here, and that's going to be equal to what's returned from the open function. And what we're also going to do is we're going to defer the db.close function. So if we're opening a connection to the database here, it is best practice to close that connection as well, and this should be a capital letter. So what we're doing here is deferring the close function. So when this main function finishes its execution, it's going to run the db.close function to close off the database connection. And that can be important for freeing up resources in a small app like this. Now let's check now if we have an error here. So what I'm going to do is create an if statement. We're going to check if the error is not equal to nil. And in the case where we have an error, we're going to call the log.fatal function. And what we're going to pass through to that is the error itself. So we're going to log that to the terminal, and we're going to quit out of the application. And finally we can check if we have a connection to the database. So I'm going to create another if statement here, and we're going to check if the db.ping function returns an error. If that error is not equal to nil, then what we're going to do is again we're going to call the log.fatal function, and we're going to pass that error through. But if we don't get an error here, we know that the database.ping function, which is just basically a health check against the database, we know that that's returned successfully and that we have established that connection. So let's save the file, and on the terminal at the bottom I'm going to use the go run command, and we can pass the main.go file to that. And we can see that we have an error here, unknown driver Postgres. So what we have here, as it says in the terminal here, we've forgotten the import of that pq module. Now we're not directly using that module in this code anywhere, but what we're going to do is we're going to create an import here, and because we're importing this package solely for its side effects, we're going to use an underscore import. And then from the go.mod file, I'm going to copy the reference to this library, and we're going to paste that into the top here after that underscore, and we need to surround that in a string as well. Let's now try and rerun this application on the terminal at the bottom, and you can see that the main function has completed execution. There's been no errors, so the database.ping function was executed successfully, and we have a connection to the database in this small application. What we're going to do now is create a table in this database called 𝗵PG test. And we're going to create a table that stores data on products in an imaginary e-commerce system. So the schema that we're going to work with, I'm going to paste a comment in here. We have a product table that contains 5 fields: an ID, name, price, available, and date created. So what I'm going to do is cut this comment out, and I'm going to create a function down below the main function here. And what this function is going to do is it's going to be responsible for creating the product table. Now in a real application you might use migrations, but we're just going to do this here so we can demonstrate some of the features of this db object that we've created in Go. So I'm going to paste the schema in here, and what we're going to do is we're going to create a query, and that's going to be a string that is going to be responsible for creating the table with these fields. Now just so that we're doing this very quickly, I'm going to paste the query in here, and the query contains some SQL here. We're creating a table, if it doesn't already exist, called product in this database, and we're then setting the fields in that table. For example, the ID field, which is going to be a serial primary key. So this is the primary key of this database table, and it's going to auto increment. We also have the name field for the product name. That's a varchar field with a 100-character limit. And we also have a price field, which is a numeric field that can contain 6 numbers, 2 of which can be a decimal. And finally, 2 extra fields. We have an available field. This is a simple Boolean field. And finally, the created field is a timestamp data type. It's going to default the created field to the current time when that item is inserted into the table. So that's our query, and this quite obviously contains these fields. So I'm going to remove this comment, and what we're going to do below this query is we're going to use our database object to actually create this table if it doesn't exist. In other words, we're going to execute this query against the Postgres database. So to do that, we need to actually use this db object that we have here. This is what we got back from the sql.Open function. So what we're going to do in our new function here is we're going to take a pointer to that as an argument. So let's take an argument here called db, and that's going to be a pointer to an sql.db object. And when we pass that in as an argument, we can then use the db object in this function to actually execute a query. Now the function that we're going to use here is the db.Exec function. This is a function that will execute a query without returning any rows. So this is important if you're performing some sort of query that's not supposed to return any data to you. You can use the db.Exec function for that, but if you are fetching data, you should use another function called db.Query that we're going to see a little bit later on. Now the argument that we're passing in here is the query, which is the string representing the SQL that we're going to execute. So that's the query that we built up on line 28 to 34. And the db.Exec function, it returns the sql.result object, and it returns an error. We don't need the result, but we do need to check if there's an error from this return statement. So what we're going to do just below here again is copy the if error equals nil. We can copy that, and we're going to paste that just below this statement here. So we're checking if the error is not equal to nil, and if it's not, then what we're going to do is again log.fatal and quit the program and print the error to the terminal. So this is our function. It creates a query string, and then it uses the db.Exec function to execute that query against the database. We then check for any errors, and that is the complete task that this function is going to perform. The only thing left to do in order to execute this and create this table is actually call the function from our main function. So what we're going to do right at the bottom here is we're going to call that function. So let's copy the name of the function, and we're going to call that and pass in that database object. And this is actually a pointer to the database object that's returned from the sql.Open function. We're passing that in, and that's accepted by our new function, and we can then use that db to execute queries against PostgreSQL. So now that we've got this set up, will it work if we run the go run main.go command at the bottom? Is this going to return anything? No, because we haven't printed anything to the terminal. But what we can do if we bring up the other terminal that we had earlier on, we can run the psql command again to get the command line access to the database, and we can then connect to our go pg test database. And there is another command that you can use in psql called /dt, and that's going to display the tables that are in this database. If we run that, we can now see that we have this table here with the name of product. So this table has now been created in the database, and now that we have the product table, we could execute a query such as select all from that table called product. And at the moment we have no rows, but you can see the 5 columns that exist in that table, and these match what we specified in this create table statement here. So that has been created in our Postgres database. What we're now going to do is we're going to actually insert data into this table using another function in Go, and we're going to see more about how to use this db object. So what we're going to do is we're going to create a Go struct that represents a product. And the fields that we need to insert, we don't need the ID field because that has this serial type. And we also don't need the created field because that defaults to the current date time in the database. So we're going to create a struct that contains these three fields that represent a new item that we might want to add to the database. So I'm going to go to the very top of the main function, and if we were using a real application, we might want to break this out into multiple files. But for now, I'm going to create a type called product, and that is a struct that's going to contain these three fields. So we're going to have the name of the product, and that's going to be a string, and we're also going to have the price, which is going to be a float 64. And the final field that we need in this struct is the available field, and that's going to be a bool type. So this struct will encapsulate the data that we need to create a new product in the database. What we're going to do now is go down and create another function that's going to take in the database pointer, and we're going to do that right at the bottom here, and we're going to change the name of that from create product table to insert product. Now this takes that pointer to an sql.db object, but what we're also going to pass in here is the data itself that we want to insert into the database. So we're going to pass another argument here called product, and that's going to be of type product, which is that structure that we just created. And from this function, we're also going to return an integer that represents the primary key of the product that was created in the Postgres table. And that's because when we call this function from our main function, we want to get back that primary key, so we can then perform further queries to get that data by primary key, just to show how that would be done as well. So let's now write the body of the function. We're going to set up another string variable called query, and we're going to use an insert into statement here. And the table that we're inserting the data into is called product, and the fields that we have data that we want to insert into are the name field, the price field, and the available field. So we're inserting data into the product table, and we have data for each of these columns. On a new line, I'm going to specify the values that we're going to insert, and rather than directly putting the values from this product into the insert statement, we're going to reference these using this syntax here. And this parameterizes the data that we're inserting, and this can be helpful to avoid things like SQL injection in your code. So for each of these three columns, we're going to insert a particular value here, and we reference these parameters. And then what we're going to do is also return the ID from this command. So when we insert the product into the table, we want to return the ID column back to the caller, back to this Go application. And that ID is ultimately what we're going to return from this function. So now that we have the query set up, we're going to create a variable in the function called pk, and that's going to be of type int, and this is going to be the value in which we're going to store the returned ID. This is a variable that's currently null, but we're going to store the returned ID from the insert statement into this variable. So how do we do that? What we can do is use a function called db.QueryRow, and the queryRow function, as it says here, it will execute a query that is expected to return at most one row, and it always returns a non-nil value. Any errors are deferred until the row's scan method is called. We're going to see the scan method right now, but what we're going to pass into queryRow is the query itself, which is the string that we built up above. And because we have these parameterized values, we now need to pass them into the queryRow function, so that when the Postgres driver is executing this query, it can fill in these values with the actual values from our product. So in order to do that, we're going to reference the product here, and the first parameter was the name, the second was the product's price, and the final parameter was the product's available field. So all we're doing here when we call queryRow is we're passing in the query, and any parameters that we have in that query string are filled in using the arguments to queryRow. So this row is going to execute the query that we have above, and that query is going to insert the product, and then it's going to return the primary key ID of that product to the application. And we want to scan that returned ID into this pk variable. In order to do that, we can chain a .scan function onto this queryRow function. And this is going to copy the columns from the matched row into the values that are pointed at by the destination arguments. So we're going to scan the returned ID into this primary key variable that we created above using this syntax here. This is a pointer to that primary key, so when we get back the ID from inserting that product, that ID is going to be scanned into this variable that we can then use throughout the rest of the program. Now the scan function, remember as it said earlier, this will return an error if there's any issues, and what we need to do is check for that by creating this error variable here. And again, I'm just going to copy the error not equal to nil statement, copy that down into this function, and if there is an error here we can again call log.fatal. Otherwise what we're going to do is return the primary key that contains our new ID. So just to summarise very quickly, we create a query here that inserts the product into the database table, and we parameterise the values that we're passing in for the name, the price and the available columns. We call the query_row function and pass in the values from the structure argument, and finally we scan the result into this primary key variable that we set up above, and that result comes from the returned ID of the new product. We return that primary key to the caller, so now what we actually need to do is call the insert product function. So let's scroll up to the main function, and I'm just going to do this at the bottom here, just underneath the create product table function. What we're going to do to start with is create a new product by using that structure that we have. So let's just give the product a name of book, and we can give it a price of $15.55, and we'll set it to true. In other words, it's going to be available. This is the last field in the structure. We're going to set that to true. So this is our product. What we need to do now is get back the primary key and call the insert product function. We pass in the pointer to the database, and we also pass in the product itself. This is going to call this function that we just wrote here. It's going to insert that product into the table and return its primary key, and that's what we're getting back here. And we can inspect that primary key by calling the format.printf function, and we can set the ID equal to that numerical pk there, and we pass the pk in as an argument. And I'm also going to add a new line to this. This is going to print the ID to the terminal when we run the Go program. So let's go to the terminal and we're going to run this application. And you can see we get back the ID of 1, and if I run this again we're going to get back another ID. And because Postgres has that serial data type in the ID column, this is auto incrementing from 1 to 2 and so on. So that appears to be working. Let's actually look at the database table and we're going to see if this is working. Now I still have the PSQL command line tool open here. When we ran this select all from product query earlier, we got back no rows, but if I rerun that now and clear the terminal, you can see that we have 2 rows in the database table now, and both of these products have the name of book and the price of $15.55. That's coming from that data that we created in the Go app using this structure here. So that has been inserted into the database, and you can also see the created column here that automatically has that timestamp when the data was inserted. So let's move on to querying for data in the database. Now there are 2 functions that we can use in order to query for data and fetch it back into our Go application. We've already seen this function here called query_row, and as it says here, it's expected to return at most 1 row from the database table. Now there's another function called db.Query which can return many rows. Now what I'm going to do is, first of all, we're going to see how we can take a primary key, for example this one here, and we can then execute a query that's going to get back that particular row from the database using the query_row function. So I'm just going to add some code here to the bottom of our main function. I'm going to clear the format.printf statement, and I'm going to create 3 variables here for name, available and price. And we're going to scan the results of a query_row function into these variables. And the query string here is going to use a select statement. We're going to get the name field, the available field and the price field from this table, and the table of course is called product. And we can then pass in a where clause. We're going to check for the ID being equal to this parameter that we're going to pass in when we actually execute the query. So the parameter is going to be the ID that we want to fetch back from the product table, and we're only going to get back these 3 columns from the table. So let's again create an error variable here, and we're going to set that equal to the db.QueryRow function. We pass the query that we created above into the query_row function, and then we can call the .scan function after that, and we can scan the results into the 3 variables that we created above here. So I'm going to copy the name variable here, we can reference that. We can also reference the available variable, and finally the price variable as well. And this should just be an equals sign here. So what we're calling is db.QueryRow, and we're scanning the 3 columns that we get back from that single row into these 3 variables that we created. We can check below if the error is not equal to nil, and we can exit the program if it is not nil. Otherwise, what I'm going to do is paste 3 statements in here, and that's the format.printf function, and we're going to print out the name, the available and price values that we're getting back from this query_row function. So remember, the variables that we're referencing here, these are the 3 variables above that we scanned the results of that query into. So let's now execute this program, and we can see what we're going to get back here. We have an error on line 35 that we have a PK that's declared but not used, and that's my mistake. When we call query_row here, we need to pass in this named parameter referencing the ID that we want to actually fetch, and that's going to be the primary key that we get back from the insert product function. So we need to pass that in as a second argument to QueryRow in order to fill out that value. Let's now try this again on the command line, and if we run main.go, we can see we get back some output for these values. The name is book, the available field is true, and the price is 15.55. So this is a different way of doing things. We have a primary key of an object in the database that we want to fetch. We use the QueryRow function because we know that when we fetch something by its primary key, that's only going to return at most one row to the caller. So we can use QueryRow for that and scan the column results into these variables above. Now what happens if we're asking for a primary key that does not exist? So if I hard code a different primary key here, and I'm also going to need to comment out the code with this primary key and the product here. So let's comment those out and run this again. We get this error from the SQL module, and that says that there are no rows in the result set. So we can handle this specific error in the if statement that's checking whether or not the error is equal to nil. So if the error is not equal to nil, we can then do another check here on the error. We can check if it's equal to an sql.err no rows. So when we get this error, we can handle that logic any way we want. So what I'm going to do in the case of no rows is I'm going to print to the terminal, no rows were found with the ID, and I'm going to hard code that same ID that we passed in. So let's try this again on the command line, and we're hopefully going to see this message of no rows found with the ID 111, and that's what we get because we're now explicitly checking for the sql.err no rows, and we can handle that specific error in this block of code. And of course, if you don't get any rows back from a query, you might not want to exit out of your application. You can handle that in a better manner. So one last thing to cover in this video: how do we get back multiple rows from the table? And then how do we iterate over each of these rows? What I'm going to do to start with is clear out this code from the main function here, and I'm going to clear everything up to this create product table statement at the top. Let's create a slice for the data that we're going to get back from the database here, and this is going to be a slice of product objects. And when we query the database for some of this data, we're going to append the results that we get back into this slice. So that's the empty slice at the moment. What we're going to do now is create a query here using the db.Query function. Notice how we're not using QueryRow. The query function will execute a query that returns rows. This is typically a select statement. So this is expected to return rows to us. The query that we're going to execute is this select statement here, where we get the name, the available, and the price fields from the product table. And we're not doing any where filtering here. This is going to get back these columns for every single row in the product table. Now once we have that statement, we can check if the error is not equal to nil, and if it's not, we can then defer this rows.close function. This is very important when we're about to iterate over these rows that are returned from the database for this query. We need to call rows.close in order to prevent any potential memory leaks. Now what we're going to do is, to the data slice here, we're going to create a product from the results of this query, and we're going to append that product to the data slice for each row in the results. So what we need to do here at the top is we're going to create another 3 variables representing the data that we want to extract from this query for name, available, and price. And then below that, we're going to iterate over the rows. So we can use a for loop here, and we can call for rows.next, and for each row that's going to iterate over the result set. And we can then, for each row, call the rows.scan function and scan the data that we're getting back for that row into the variables that we have above for name, for available, and for price. Now the scan function might return an error, so we're going to check for that here. So we get back the potential error from the scan function, and we can check if that's not equal to nil. But if it's not equal to nil, what we're going to do is we're going to create a product structure from the data in these 3 variables after we scan the results from that row into those variables. And we're going to append to this structure that we have at the top here called data. So that contains nothing by default, but the results that we get back from the database, we are going to use the append function on a slice in Go. We can pass in the existing data, and then what we're going to do is create a product struct from the data that we have here for the name, for the available field, and from the price field as well. And then after the for loop finishes, what I'm going to do is print out the data to the terminal so that we can see what that looks like when we run the command. So let's quickly go over this before we run this code. We set up the empty slice, and then we execute a query that gets back all of the results from that product database table and stores that in a variable called rows. We defer closing that data, and then we iterate over each row in the data, and for each row we are scanning the results from that row into the 3 variables that we have here, and then we're creating that product structure from the results and appending it to the slice. Let's now execute the query at the bottom and we can see what results we get back, and we're getting back a list containing 3 structs. And that's because there are 3 objects in the database which we can verify if we run this select statement in PSQL again. So we have 3 rows, and when we run the application we get back those rows represented as structures after we convert them here and use the append function. So the important takeaway from this is that when we want to get back a single row from the database, we can use the db.QueryRow function, and that's either going to return 1 row if we find any data, or it's going to return no rows if we don't have any data. We also have the database.Query function that we have here, and if we expect to get back multiple records potentially from the table, that's the function that we should use in order to do that. And as well as query and query row, we also have the db.Exec function in Go, and this exec function will execute a query without returning any rows. So if you don't need to get back any rows, for example you're performing an insert statement that doesn't return the ID, you can use the db.Exec function in order to do that. But that's all for this video. There's much more that we could cover in a future video if you're interested. For example, we could look at database transactions in Go, we could look at prepared statements, we could dive into ORMs that are available in Go, and we could also look at libraries such as SQLX and SQLC that can work in different ways with databases in Go. But thank you for watching this video. If you've enjoyed the video, please like and subscribe to the channel, and we'll see you in the next video.